Good morning, guys. Take number 5896. My computer keeps crashing every time I go through here. Maybe I can make it this time. I'm going to try to make through this really quick. I want to switch out these directions on the top, explore the following limits on your graphing calculator, identify the limits, and then try to make some algebraic sense of them. So what I'm going to try to do is I'm just going to see if I can make some algebraic sense out of these for you and then graph it, okay? That's my plan anyway. So bottom line, I have an absolute value over a polynomial, okay? If the absolute value was not up there, it's basically a rational function. But remember, all that absolute value does is when inside is negative, it spits out a positive number, right? And I can tell it's going to be negative, the inside, as soon as x is less than 5/6, which would be what? I don't know, 5 divided by 6, whatever the heck that is, a little bit less than -1. Anything less than that, it automatically turns things positive, okay? Well, so what we're going to do is we're going to kind of picture this just like a rational function. And if I'm putting infinity in here, okay, and I'm just going to write this out, 6 times infinity plus 5 over 3 minus 2 times infinity, my question is, this is a big minus, my question is if I'm taking 6 times infinity, okay, I think it's pretty safe to say this plus 5 isn't going to do squat to it. The same way if I take 2 times negative infinity, realistically I'm adding 3 to that. That measly little 3 is not doing squat to that function, right? I think we can all understand that. So what I'm trying to do is I'm trying to get you to say, hey, we're going to compare this basically using the power thing. And the power thing, really what I'm looking at is 6x over negative 2x, okay? Well, that looks like a 16, but that's an absolute value bar. Well, what I'm plugging in is a positive infinity, okay? So what I'm doing is I'm thinking, well, I know the numerator is always going to be positive because it's absolute value, so no matter what I put in, the numerator is going to be positive. The denominator, if I put negative infinity in here and I take that times -2, or if I put positive infinity times -2, my denominator is always unconditionally going to be negative, correct? Regardless of anything. So what I'm doing is I'm going to see a positive over a negative in the end. My numerator is going to be positive, my denominator is going to be negative. Now, when I'm coming back to this, what I'm going to do here quick is I'm going to come back, but I had to do that analysis with the numbers to see what sign I'm going to have. And now I'm going to reduce it. I'm going to reduce that x, and I'm going to reduce that x. So realistically, I have 6 over -2. So what I'm going to tell you, and I'm going to show you with a graph, is the limit of this ugly function right here as I go to positive infinity. Remember, that's the right side of the graph. That's a right-hand end behavior. It's going to be getting snug as a bug in a rug to -3. I'm going to have a horizontal asymptote at y equals -3, okay? That is going to be my right side end behavior. Well, let's take a little gander of the left side here, okay? Well, again, I'm going to do that little power thing. So in the end, it's going to be 6x, make those bigger, over -2x. But what I need to think about here is I need to think about my sign now, okay? I'm plugging in negative infinity. It's coming in here. Well, I don't care what I plug in there. I'm still going to have a positive number up there regardless, okay? But if I put a ginormous negative number in for x and I take it times -2, well, that's going to give me a positive number in the denominator. So that's going to give me a positive over a positive. This is just a little something we gotta realize, okay? And then from there, what I'm going to do is I'm going to erase all this business, and that was my explanation to you. So I'm going to do that power thing, and I'm still going to have my 6x over negative 2x. But like I said, when we're putting a negative in, what's going to happen is this negative right here is going to go away. What it's going to do is it's going to make my numerator positive and my denominator positive. And now I'm going to do a little analysis and reduce these x's, but I couldn't reduce them prior to my analysis because that negative number is going to turn the bottom positive. And then I can see that that's actually going to be 6 over 2 or 3, meaning I have a horizontal asymptote at y equals positive 3 as I go to the left. And now I'd expect somebody to say, yo, if you are all here, yo, Mr. Kruger, how come there's 2 horizontal asymptotes? We were always told you could only have 1. Well, that is only with rational functions. This is not a rational function anymore once that absolute value's in there, okay? It's not a polynomial over a polynomial. It's an absolute value over a polynomial. Well, let's see. Hopefully you followed that. Now let's toss that little pot liquor on our grapher here. And I'm going to say graph, do my control divide. Now, if you want the absolute value, it's right next to the notebook here. And it's this guy right here. Click that. And I need a 6x plus 5. 6x plus 5. That's over 3 minus 2x. Blammo! Look at that crazy little graph, okay? That's weird. That's really weird. Let me graph one other thing in here with you really quick. I don't want to make this long, but I really want to make sense out of this. If there were not an absolute value on the top, 6x plus 5 over 3 minus 2x, we would have this red rational function. But remember I said as soon as this numerator, as soon as I plug in an x, okay, that is less than negative 5 over 6, solve that for 0 in your head, it's negative 5 over 6. As soon as that's going to turn this numerator negative, okay? But the absolute value pops it out positive, and when I'm putting any negative number in here, that makes my denominator positive. So from that negative 5, 6, what it's doing is it's cutting this little chunky monkey off right here, and it's going, whoop, you have to stay positive, and that's why it does the old bounceroo off of there, and it goes up. Let me delete that. Crumb. Now let me get this. Let me come up. Let me delete that. Enter, so we're back here. Well, let's check it out. As I'm going to positive infinity, how did we graphically find these limits? We went menu, trace graph, maybe 1,000. Bam, negative 3. Maybe 10,000. Get bigger. Negative 3, I'm coming up from the bottom. So as I went to infinity, my limit to the right was 3, my horizontal asymptote. How about negative 1,000? Where's my, ooh, look at that. It's coming, it's flattening out at 3. Even if I went to, from negative 10,000, it's still approaching 3. I can see that right on there, okay? So that hopefully helps you out with that graph. When I have absolute values over things, I can kind of use that power thing. But I also have to remember to check the sign, like I said, when it's coming in here in a way. So remember to carry the sign, because that absolute value, basically what it does is when the function, if you graph the same function without the absolute values, whenever that thing, and I don't want to say goes negative, because then you're going to be like, well, Kruger over here, it's not negative. Let me get a window. Let me get back to a standard. Down here it's negative, but there's an absolute value. Well, these are all positive numbers here. The top is always positive, and as I put in a positive x in the bottom, the denominator is always going to spit out a negative number. Therefore, that's why that is down there and it didn't come up. It's only controlling this portion over here. Okay. So what I'm going to do is I'm going to move on to the next one. This next page, find the following limits. If there's no limit, state if the function is approaching infinity or negative infinity. Well, hopefully we can see these are all one-sided limits, number one, with the little superscript up there. And number two, hopefully we can see really quick, if I put 2 in here, I do have 0. No, I don't. I have, okay, like for number 1, I have 2 over 0. Yeah, that means my limit does not exist. I have a vertical asymptote there, but they're asking me, and that's exactly, if you ever get a limit that says negative infinity or positive infinity, that means the limit does not exist. However, sometimes they want you to state which way is it going, up or down. So what we're going to do is we're approaching 2 from the left. So that would be a really small number, 1.999. Remember, we can put the number in right in the top. I got 2 over. This is going to be negative small, right? Which means something divided by a very small number, it's going to be negative big, going to negative infinity, going down. Letter B, if I put a 3, negative 3 in there, well, I got negative 3 over 0. I get another one, does not exist, but they want to know which direction is that little bugger going. So I'm approaching 3 from the right side. That means I'm putting negative 2.999-ish in there, okay, which is going to take me to negative 3 over negative 2.999 plus 3 gives me positive small. Something divided by something smaller, 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 going to give me big, but this is negative big because of my signs, okay? Now we're going to come down to C here quick. And C, well, if I plug it in, negative 2, I get negative 2 over 0. Yeah, does not exist. We knew that. It's a real quick one, but they're saying which way does it go? Well, if I'm coming to negative 2 from the left, that means I'm coming at about negative 2.001. Well, that's going to give me negative 2 over negative 2.001 plus 2. That gives me negative 0.001. But when I square that, it turns to positive small, which means we are going to negative big. Okay? Makes sense, hopefully. The next one, the last one, people hate because it's got a little bit of trig in there. I don't like it this way. I'm thinking of what is the limit as x approaches pi over 2 from the right of 1 over secant would be a cosine x, thinking of my trig identities, okay? Well, the cosine of pi over 2 is 0, so that's going to give me 1 over 0. Does not exist. Duh. Okay, but now what I need to remember is if I'm approaching pi over 2, I can think of this 2 ways. 1, 2, 3, 4. Here's my pi over 2, pi, 3 pi over 2, and my cosine is going to go from 1 to negative 1, and I bebop down. Okay, I personally picture my graph for this guy. And so I look at this and I say, okay, as I'm approaching, here's my pi over 2. As I'm approaching pi over 2 from the right, that would be coming up here. What I'm seeing is I'm seeing 1 over, that's going to be all these points down here are going to be negative y values. Therefore, it's going to be negative small, which, what would that mean? Negative small, that would mean 1 divided by smaller, smaller. That would be negative, very, very stinking rotten big, right? Or if you don't like that, you can picture, here's your unit circle, okay? Here's, and it really doesn't matter because here's my pi over 2, and here's pi, 0, 3 pi over 2. Well, if I'm approaching pi over 2 from the right, meaning which way do we rotate? Well, we rotate this way, right? So as I'm approaching pi over 2 from the right side, I would actually be approaching it over here, because I'd be past pi over 2, coming back to it if I'm approaching it to the right, the same way I'm thinking here, okay, on the graph. Notice all these points over here, all these points over here are a negative value, a positive value. Negative is my cosine. That's why I'm negative small, and when I'm just over pi over 2, I'm really tight to the x or the y-axis there, so that's why it's so small. Hopefully that can ring a little bit of a bell there. And I'm going to move along here to the last one. We're just going to look at this. We're going to find the limit. Actually, I think you have 5 ways on your sheet, and I'm just going to do this quick. Well, this is a piecewise function. This piecewise function is made up of 2 different rational functions. This actually is an old AP question, okay? So what I'm going to do is I want to see, A is saying, what is the limit, as x approaches negative infinity? Negative infinity. Well, which one of these is going to negative infinity? Well, this is x is less than 0. So this is the side when I'm going to negative infinity. So the limit as x approaches negative infinity of x minus 2 over x minus 1, what does that equal? Ooh, like I said, it's a rational function. I'm getting way, way big. Big, 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 big. End behavior. Power thing. 1. Bada bing, bada boom. B, what is the limit as x approaches positive infinity? Positive infinity. X is greater than 0 here. This is where I'm going to positive infinity. Okay, so that's going to be a 1 over x squared. Okay, I'm going to infinity. Horizontal asymptote. Big in the bottom. 0. Y equals 0 would be my horizontal asymptote. Okay, so I'm cruising and bruising here. The limit as x approaches 0 from the left in C. Limit x approaches 0 from the left. Which one of these is approaching from the left? Well, if I came back here and I looked at it, well, x is less than 0. Here's my left side. Here's my right side. So if I'm approaching from the left, I have to be approaching on the top piece of the function, which gives me x minus 1. Remember, we direct substitute in right away. Plug 0 in there, I get negative 2 over negative 1. Oh, my limit is 2. Beautiful. That's not a horizontal asymptote there, but that's my limit. And now we're going to approach 0 from the right. So that's going to be limit as x approaches 0 from the right. My right side is right here. I'm approaching 0, 1 over x squared. Okay, what is my limit? Now notice this is a one-sided limit. I'm approaching from the right side. If I put a very small number in there, maybe, I don't know, 0.001, what I'm going to get is 1 over, and then I got to square it no matter what. I get 1 over positive small. 1 over positive small gives me direction, infinity going down, which also means does not exist, okay? Well, why is it going down? There's an asymptote there, okay? I do believe you should be able to look at these 2 pieces of the function. I believe you should be able to look at the top piece right here and say the domain's stated, so I'm not even going to state that. But on this top piece, okay, x is less than 1 on this piece. When x is 1, it doesn't get in there, but I can see a vertical asymptote at 1 for this piece, but I can see a horizontal asymptote there as well at positive 1. Down here, x is greater than 0. Okay, well, 0, vertical asymptote at 0, vertical asymptote at positive 1 there. We could make a little graph of that in our grapher. We could do it. I'm not going to do it. And I think the other one that's on there is they wanted the limit, I think you guys have a part E on your note sheet that I forgot to put on here, which is the limit as x approaches 0 of f of x. That's the whole function. So one side I'm approaching at 2, one side I'm approaching at negative infinity. So I'm assuming that that does not exist, and it's approaching 2 different values. Let me go check it out. Have a good day.